Good morning, students. I am Sindhu A. Nair from KV NAD Karanja. I am starting with the lesson Polymers. Polymers is a small lesson having 3 marks for your board examination. And this many polymers you are familiar with in your day-to-day life. So, in polymers, what are the content mainly I have to cover is, the first content is what are polymers? What are polymers in the sense, polymer means it consists of two words merged it forms. Poly means many, mer means units. Many units combined together and it gives rise to a bigger molecule or bigger unit having a high molecular mass, which is known as polymer. All the polymers are made up of basic units. That basic unit is called a monomer. For example, ethene. CH2 double bond CH2, this is called ethene or ethylene. This molecule, when it combined with another molecule of ethene, this bond, as you know, it is a purely covalent bond. This bond will break, here it will break, this bond also will break, here one valency created, here one valency created, this carbon also holds one valency. It combines such a way that these two carbon combine together, so that you can see it like this, CH2, 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 here one valency. The particular species, again one more ethene molecule added, here if we add one more ethene molecule, this bond will break and here one valency created, that automatically will be added here. So, the chain continuously growing. So, this polymerization, you can see that if I write NCH2 double bond CH2, it will polymerize and give you CH2 single bond CH2 n times. Or if I write this chain in a straight way, the basic unit you can feel that this is a basic unit. From this basic unit, the polymer is made up of. The basic unit with which a polymer is made up of is called monomer. Monomers combine together or polymerize together to give a long chain of polymer. Now it comes to classification based on mode of polymerization. Polymers polymerize in different way. Based on the mode of polymerization, how they polymerize, it is classified into addition polymerization and condensation polymerization. One is addition polymerization, other one is condensation polymerization. Addition polymerization you have seen, ethylene polymerized to give polythene. Polythene you are very familiar, polythene carry bags and all you are very familiar. The addition polymerization, monomers add end to end and form a long chain polymers. This is also called addition polymerization. We call it as, in the sense, it is 2 category it comes. In addition polymerization, first category, it is homopolymers and second one is copolymers. In homopolymer, as the term indicates, there is only one type of monomer species includes. Only one type of monomer species includes. One more example I can write, other than polythene, you know vinyl cyanide. It is also called acrylonitrile. Vinyl cyanide on polymerization. Here these two carbon, this bond will be breaking, these two carbon you will be getting valencies. CH2, single bond CH2, here it is Cn, here we will write n times. In the sense, this is a basic unit which is repeating, or the monomer is this. This is polyacrylonitrile or polyvinyl cyanide, or it is known as PAN. Polyacrylonitrile or polyvinyl cyanide, it is known as PAN. This takes place as a chain growth. Chain is continuously growing, one molecule added, 2 molecules added together, then the third molecule will be added here as I have shown here, then the fourth molecule. So, the chain is keep on growing, so it is called chain growth polymerization. Moreover, it is a homopolymer, only one type of monomer is involved. Now, if it is a step growth polymerization, Step growth polymerization, what it is it clear to you what is homopolymers and what are copolymers? I have to come to copolymers. Copolymers, two type of monomers, two or more than two type of monomers are involved. For example, 1,3-butadiene, nylon 6,6. Yeah, Buna is 1,3-butadiene plus styrene it combines. Here there is a double bond, this you should clearly understand. This bond will break, this bond will break, one valency created in these two carbons. These two will combine, so there is a double bond created here. These two valencies are existing, so I can show it here. This double bond will be breaking, here one valency created. As it is previously it was like this, you can make it out, I will write it here. CH2, single bond CH, again single bond CH, single bond CH2, here one valency, these two valencies combine, plus this case CH2, CH, C6H5, these two bonds combine together and you will get CH2, CH, double bond CH, single bond CH2, CH2, CH, C6, H5. This is a single unit, means addition, means I am talking about copolymers, two type of monomers combined together, this is styrene, this is butadiene, two different types of monomers combine and you get a polymer, but it is an addition polymerization. Addition means added together, monomers added together. It is an addition polymerization. First case you have only one type of monomer, here you have two different types of monomers. There was a mistake here, as you know carbon has got only 4 valences, this is CH only, since this is also CH. Now the best example which I can depict is for homopolymer, look at this chain, all the beads are alike, you can consider each bead as a monomer, so it polymerizes and you got a bigger chain having a big molar mass, molecular mass I mean. This is an example of copolymer, you can see. This each bead you see, this is one monomer, this is another monomer. So two different monomers are combining, so you got a chain, polymeric chain which having two different monomers. We were discussing classification based on mode of polymerization. In that addition polymerization has two branches, homopolymers and copolymers, two different type of polymerization we have discussed. Now it comes to condensation polymerization. Starting with the mechanism of addition polymerization. Addition polymerization always takes place in presence of a catalyst like benzoyl peroxide. This takes place either in presence of sunlight or at high temperature. This reaction, as any photochemical reaction, this reaction also consists of 3 steps: chain initiation, chain propagation and chain termination. In chain initiation step, in presence of heat or sunlight, the benzoyl peroxide undergo cleavage, homolytic cleavage and produce free radicals. You can see here this is a benzoyl peroxide molecule. It will homolytically cleave and it produce 2 free radicals which again cleave. Here you can see it cleaves here. It gives benzyl free radical and carbon dioxide molecule. This free radical in turn attack ethylene molecule. This again, this double bond will homolytically cleave and the polymerization begins. This is a chain initiation here starts or polymerization reaction begins. This free radical, as you know, it is highly reactive. It attacks next ethylene molecule. Again this bond will homolytically cleave, this carbon will be attached with this, and this end become a free radical entity. This further attack another ethylene molecule, and this propagates. So this step is chain propagation. The reaction will keep on going. So you will get a bigger molecule. So somehow, but the reaction will be keep on going, somewhere we have to stop the reaction. So the chain termination step, such two bigger entities combines in the sense this molecule C6H5, CH2, 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 N times. This entity combined with a similar molecule, one more molecule of like this. So I am writing from right to left, CH2, CH2, this is a free radical. I am showing this valency here, CH2, CH2, C6H5, this is N times. When they combine, you will get a bigger polymer, and the chain reaction stops also. Here it combined, the reaction stopped here. So these are the various steps of addition polymerization. I hope it is clear to you. Next it comes to condensation polymerization. Condensation as a term means two different functional groups combine, eliminate either a molecule of water or a molecule of ammonia or something like that, and you will get a polymer. Here nothing was eliminated, it was a simple addition between a double bond or a triple bond. There we are eliminating a molecule of water or some other species so that you will get a polymer. Next is condensation polymerization. In this, as I told you, we will try nylon 6,6. You are familiar with the nylon ropes and all. Nylon 6,6, the monomers are adipic acid and hexamethylene diamine. Adipic acid is CH2 4 times COH, it is a dicarboxylic acid, and hexamethylene diamine, as it indicates, it is 6 methylene groups and 2 amino groups. You are familiar, when an acid combined with an amino group, the expected functional group is an amide. So this OH and one H will be removed, this OH, and from here one H will be removed. So your compound will be CH2, COOH, CO, NH, four times, CONH, this is 6 times, CH2 6 times, NH2. This is an amide. As you know, this end is a carboxylic acid, this end is an amino group. Here suppose one more acid group, adipic acid, if it comes here, this H and that OH will condense. So this hydrogen always will be removed by that acid. Suppose here one acid group comes, OH, COH, this is an acid entity, this H and that OH will be removed. So we show always this as a valency, NH, because it is always condensing with the OH of carboxylic acid. This end, this OH will be condensing with that NH. Suppose here hexamethylene diamine comes, one H will combine with this OH. So this OH will be always going. So we show it as a valency. Then we can write this is N, so that this is N times. This polymer is called nylon 6,6. Why this 6,6 comes? The monomer unit contain, this is adipic acid, which contain 4 plus 2, 6 carbon atoms, and here hexamethylene diamine also contain 6 carbon atom. We call it as nylon 6,6. This is a condensation polymer. It's an amide, it's a polyamide formed by the condensation of adipic acid and hexamethylene diamine. Next it comes, we were studying classification based on mode of polymerization. Now we are going to study the classification based on intermolecular forces. Intermolecular forces, you are familiar, how the intermolecular forces operates, or whether the intermolecular forces are very strong, the substance will be rigid or it is stronger. If it is weak, the substance will be weak as it is. For example, rubber, you are very familiar with rubber band, it is very much stretchable, in the sense intermolecular forces are weak. And in case of, for example, the classification based on intermolecular forces, we can classify it as elastomers, second one fibers, third one plastics. This you are familiar, plastics are two types, thermoplastics and thermosetting plastics. First case, elastomers, the rubber band you are familiar. The intermolecular force of attraction is weak, so it is stretchable. Fibers, the intermolecular force of attraction is very strong. For example, nylon ropes you are familiar, the intermolecular force of attraction is very strong in this. Plastics, the intermolecular force of attractions are in between elastomers and fibers. It is in between elastomers and fibers. So, these plastics are two types. One is thermoplastics, other one is thermosetting plastics. Thermoplastics we are familiar, our home people come and take the broken buckets, broken cups and all for recycling. The plastics which can be recycled, which can be heated, after melting it can be molded, such plastics are called thermoplastics. The plastics after heating it gets set. For example, plastics can be recycled, as you know. That plastics are called thermoplastics. The one which cannot be recycled or which cannot be, after heating it got set, it will not melt and it cannot be remolded. Such plastics are called thermosetting plastics. As you are familiar, this is a fiber. As you are familiar, it is very strong. It cannot be, intermolecular force of attraction is very strong in this. This we all use it. This is a rubber or it is an elastomer which has got a weak intermolecular force of attraction. With its stretching you can make it out. This is thermosetting plastics. This plastic when you heat it it cannot be remolded. This is an example of thermosetting plastic which we normally use it in house. This is a scissors handle it is. Now it comes to various polymers which we are familiar in our day-to-day life. First one was polythene, which I have discussed. Normally examination